Friends, welcome to the virtual classroom on the online course titled Health, Safety and Environmental Practices in Offshore and Petroleum Engineering. This is an NPTEL course from IIT Madras. We are discussing lectures on module 2. I am sure you must have gone through the lectures on module 1 and of course 8 lectures on module 2 as well. In module 2, we are essentially focusing on operational safety. In this lecture, which is 9th lecture in module 2, we are going to talk elaborately about the risk assessment and accident analysis. Prior to that, we will also solve a small example on Frank and Morgan risk analysis. So, in the last lecture, we discussed about Frank and Morgan model, which actually gives a risk picture in economic perspective. And we all agree now that if the risk picture is not given with an economic perspective, it has no commercial sense of meaning as far as offshore industry is concerned, because offshore industry business activity is one of the vital activity in the government sector or in any nation in the economic growth. Therefore, one should really know what is the influence or what is the consequence of an accident or a risk picture in economic perspective to really gain importance. So, if risk is connected to economic perspective, I think we all agree as an engineer and technicians that risk will gain more importance. The moment risk gains more importance, the window is widened, obviously risk propagation can be controlled and risk mitigation measures can be initiated, and all catastrophic accidents which happened unintentionally, really they were accidents in offshore industry, they could all been avoided at least in the coming future. So, let us take a very interesting example and see how Frank and Morgan model can be simplified tool to apply risk analysis and what are the interesting outcomes of this example. As I said, let us take a process plant. I will take an example of a process plant. Without naming the plant and without naming the departments, I would divide the plant into different departments A, B, C, D, E and F. So, there are 6 departments. Okay. As we all know, we want to find the hazard score and control score of each department, which actually depends on the checklist prepared by this industry or this plant, based on which we do an inspection. We did an inspection, we tried to identify the hazardous situations in each department in the given plant, and of course, we also inspected the control measures what each plant or each department had in position in place, and then we also estimated the composite exposure value of each department in consultation with the people working in the department, as well as looking at the stock and inventory of the department and so on and so forth. So, I will not go into the detail of what inspection was conducted etc., because that is not the part of this particular discussion, but however, we all know as an experienced professional this can be always consulted and this can be obtained. But however, let us have a summary what we already had. So, the summary is what I am presenting here. Let us say the exposure department, this is table 1, I should say the given data, this is the given data for the problem. Okay. Let us say the exposure department. I will always use the term exposure here, because risk is always effective only when the person exposed to risk is actually handling the risk management. Okay. Then we will talk about the hazard score and of course, the control score, which has been obtained for each department after conducting detailed inspection meetings etc., preparing a checklist, all has been done. Then property value, that is asset of each department. I will put this asset in terms of US dollars and multiply this value with 10 power 3, and this is in US dollars. And business interruption cost, again I will multiply this with 10 power 3, again the value is given in US dollars. And then I will also have the personnel exposure value, then all put together is my composite exposure value, which I will enter here in US dollars. So, I am entering the CEV value in US dollars in of course 10 power 3. Let us prepare a table. Let us have this data known to us for 6 departments. So, let us the departments are A, B, C, D, E and F. The hazard scores are entered here. Let us say this is 257, this is 71, this is 181, this is 152, this is 156 and this is 113. The control scores available in each department after inspection was found out to be the following: 304, 239, 180, 156, 142 and 336. Then the property value is given again in US dollars, 2900 10 power 3, that is the asset value, 890, then 1700, then 290, then 520 and 2910. If you look at the business interruption cost of each department in terms of US dollars 10 power 3, this is 1400, this is 1200, this is 720, 418, 890 and 3100. Similarly, the personal exposure value 900, it is 653, 1610, 642, 460 and 1860. So, I want to combine these 3 to make this sum. So, if you add them up, I get this as 5200 and this as 2743 and this as 4030 and this as 1350 and this as 1870 and this as 7870. That is the data given to me for doing the risk analysis. Let us quickly diagnose this data and see what observations can we make from the data. The observations what we make from the data are the following. We make from the data. One, the department A compared to F, let us say, the composite exposure value of the department F seems to be the highest. So, seems to be the most important department in the whole production line, whereas the department D seems to be the composite exposure value seems to be the lowest, and therefore, the contribution or the influence of this department on the whole production line is least. So, please understand the statement carefully. We are not comparing the department depending upon the importance, all departments are important HR is important, drilling is important, production is important, store inventory is important, marketing is important, all departments are important. We are not saying anything about that. Please understand the contribution of this composite exposure value comes from the 3 segments as you see here, and reasonably the business interruption cost as expected is highest here. So, it indicates to me very clearly that this department has maybe the lifeline concept of the whole production system. So, that is the first observation we can make. So, one we can easily find which is the most important department looking at the composite exposure values. One can look at this. The second observation one can make is looking at the hazard scores, one can feel that the department A seems to be most hazardous compared to department B. Then parallel look at the control scores, department B which is having the least hazard is reasonably having a better control score also. So, expected to qualify for something like a reference department because the control scores are very good, but however, the highest control score is on the department F, which is also one of the important department in the lifeline or the production system of the product line, and the hazard levels are also not reasonably higher compared to A, so it is lower. So, one can easily see from this picture the department F is able to manage hazard and the risk management in a proper manner in the past years, so that even though they become the lifeline of the product system because of the composite exposure value, they have reasonably a very good control score. Okay. So, this is a very quick analysis what we can make. So, one can simply see which department has done better in the past. I mean, one can get this inference also. Okay. We will extend this table now. I want to get what we call so, friends, let us try to now compute the risk index in step number 2 etc. So, step number 1 we have just quickly tabulated the value. In fact, we are able to get the CEVs of different departments and we are able to get some quick information only from the data. I mean, this itself can be a first level of hazard assessment, okay, because we are able to relatively understand which department was performing better, which department is highly vulnerable, which is most important in terms of production line, all we get an information from this. An experienced personnel looking at this table will be able to make out some more information also from the data, but however we will proceed further to the step number 2. So, step number 2 I want to compute the risk index. I will do it here itself. In fact, step number 1 itself is actually the risk index. So, let us compute the risk index. Step number 1 we will get the risk index itself because this is the data only. This step is only the data. This is only the data. We could make some information from the data, but that is irrelevant, that is okay. But let us try to do step number 1, risk index. Risk index we already know that it is a control score minus hazard score. So, let us try to do that 304 minus 257. So, I get 47 positive. So, I do not write positive because we know that, but negative we do write negative. So, 239 we have a better control score here. So, expected to be positive. So, that is going to be 168. Similarly, the next one is going to be 180 against 181. So, I get minus 1 here, it means it is bad, control scores are inferior compared to the hazard scores. Similarly, here is going to get plus 4. So, I am writing simply 4. Similarly, here is going to be the control scores are lower than this, I must get minus 14, and 336 is far better than 113, therefore, I get plus 223. So, a best control score or the best risk index is seen in department F as expected in the first information, because department F had a very good control mechanism. It seems in place compared to other departments relatively. So, please understand, you cannot use this table for comparing two different plants. Please understand this. This is relative ranking, relative risk indexing only within the plant various departments. You cannot compare two different plants, because the operational, the seasonal variations, the composite exposure values, because exposure values as we saw from the first module, they also depends on climate, temperature, weather, humidity, sunlight, there are many factors. Okay. So, one cannot simply compare this data for two plants A and B located different latitude longitude and I am going to compare. No, you cannot do that. This is relative within the plant, because these departments, please understand, are connected to a single production line of the same plant. Okay. They should be anyway directly or indirectly connected to the production line, otherwise there is no composite exposure value meaning at all. Okay. If this is some head office somewhere located elsewhere, I cannot connect the head office to my risk analysis of a plant, because this is no way involved directly or indirectly in the production line. Thus, the exposure is what we are looking at. Okay. So, all these departments are located in the same campus where the production is happening. Therefore, exposure is a concept here. Please understand this. We are not looking only the values of this. So, I compute the risk index. From the risk index, I do the first level hazard management. I can easily understand the departments which have the negative numbers are dangerous, because hazards are far higher compared to that of the control score. So, they should be paid attention. So, I can develop an inference here. So, from step number 1, I do first level hazard management. Departments, let us say E and C, should be paid attention. Let us put a mark like this here, and department F, which is the highest, and department B can be considered for rewards, because the risk index is positive, it means the control scores are far higher. This is the first information we have from step number 1. Let us see how this is getting redefined. Okay. So, after doing risk index, in step number 2, we are supposed to compute the relative risk. Let us do that. To compute the relative risk, I have to identify the base reference department, which is the best department. The best department is that department whose risk index is maximum positive. Positive indicates the control scores are far superior. Positive number highest indicates the department is the best. So, if you look at this figure of risk index here, 223 is considered to be the highest positive number in the given data. So, department F is considered to be the base reference department. So, if I do the control score of the risk index of the department with that of the base reference department, deduct that, I will get 0 here, because 223 minus 223 will be 0. Now, what I should do is here, to compute this, I should say 47 minus 223. It should not be the other way. Okay? It is this department should be compared with the best. It is not the best department should be compared with this. Please do not do that. Okay? So, it is interesting that all the relative risk scores, what you will be getting in calculation should be negative. So, it is an indication in the table that all departments are inferior compared to the base. So, 0 and negative, if you look at that mathematically, all departments are inferior compared to the base reference department. Therefore, 47 minus 223 and so on and so forth, let us do that. So, this is going to be minus 176. So, this is minus 55, this is minus 224, this is minus 219 and this is minus 237. You will always notice and check the one which are already negative will have further increase than this number. Okay? They are further worse, because they are already worse and they become still worse compared to department F. So, relative risk can be easily computed, and the check here is, okay, let me write it is equal to, okay, minus 176. So, all will be indicated negative and we can do that. Okay. In the step number 3, what we are expected to do is a percentage risk index. How do you do that? So, let us sum up the relative risk. Let us add this and take a mod value of that. So, the sum is going to be 911. Okay, if you sum this all, I mean neglecting the negative sign, sum is going to be 911. I want to compute the percentage risk index of this department. This can be easily said as risk index of the department, which is relative risk index of minus 176 by 911 into 100. Okay. So, it is going to be, let us see, we can calculate, it is going to be minus 19.31. Okay. Similarly, you can calculate for all the departments, it is going to be minus 55 by 911 into 100. So, that is going to be minus 6.04 minus 24.59 minus 24.04 minus 26.02, and this will be 0. And if you add them all, it should become 100. Okay. Now, in step number 3, that is this column, let us name the columns. I am leaving this column as data. I say this is column number 1, this is column number 2, column number 3. Risk index is nothing but control score minus hazard score. Okay. This is control score minus hazard score. So, if you want to really get the breakup of 47, it is nothing but 304 minus 257. That is how we got 47. Okay. That is how we got 47. So, this remaining all can be worked out like that. So, let us write information now. From step number 3, we get further information. Step number 3 indicates that department F is the best, it is the base department. In fact, rather we got it in step number 2 itself, does not matter, but anyway. We also know that all other departments showing a negative index indicating they are at risk compared to department F is obvious, because department F is the best reference department. Now, let us compare the percentage relative risk index. Now, these are relative now. I am comparing A with F, I am comparing B with F, that is what I am trying to do here, is it not? I am comparing A with F, okay, that is what I am trying to do here, that is why I got this. This number belongs to F, okay, that is why I got this. So, now one can see here, they are all going to be the percentage contributors to the overall risk. The overall risk in the plant is 100. The overall risk in the plant is 100, and the base reference department does not contribute to any risk at all. Okay, that is why it is 0. So, one can see here from this that department B contributes to the least, and departments C, D, E almost contribute equal. I mean contribution to risk I am saying, okay, contributes almost equal. Please understand, the composite exposure values of these 3 departments are significantly different. The control scores of these departments are also different. The hazard scenario may be equal, but they are different. Okay? But when you apply the percentage and compare relatively, they become more or less close contributors to risk. This is how department's risk will get aligned to the risk of the plant. Individually they are not, because all of them, you see, all of them have good, especially let us say, it is very pity to see the department D in this dialogue. because department D had a positive score. It means it has a better control than the hazard in comparison to these two departments, but department D is also dragged in the same line as that of C and E when you start relatively ranking them. That is the problem here. So, risk actually is an alignment of mistakes. Individually you may be good, but a small error committed by you will overcome the positive contribution of the other department and you get aligned in committing to risk. So, accidents are alignment of mistakes. You may feel, you may say that my contribution is very good, sir, it is positive, but your positive will be eaten away by the negative aspects of the other department. That is the difficulty here. Then one can ask me a question, sir, how this is not eaten away by this department? Because the positive feed of this department is so significantly high, even the negative issues could not even go nearby them. So, you as a department representative should perform extremely well towards risk management, so that other, even there will be a mistake, you cover up that mistake and avoid accidents. It is like a multi-legged race. You are one of the legs in the race, but you carry the remaining legs along with you, and even though they may not run at the same pace as you are running, you still win the race, because it is a multi-legged race. So, you have relative understanding between the departments, that is why we say. So, this method is very interesting. It also debugs the weakness and strength and brings out cordial understanding between the departments and tells where the departments stand compared to the reference department. That is very, very interesting, which is required as a HSE manager, is important. So, step number 3 gives me a relative risk index in terms of percentage. All these are percentage values, okay, I have indicated here, and you should sum up to 100. Okay. Now, till here is risk assessment, which is conventional, which is mathematical, which is probabilistic, which is frequency based, etc. Whatever you want to feel, it is all fine here. But in oil and gas industry, being a very vital sector in economic participation of the economic growth of the country or a nation, or let us say world's economy, we cannot simply stop risk by a number here. I want to convert this risk in terms of financial figures, otherwise I am not happy. I have to tell my board members that what does this actually plan tells in terms of risk assessment, in terms of financial figures. My stakeholders will be interesting to know, will it cause a economical damage, dent in my investment? They would like to know this. So, my risk assessment should converge to economic perspective, otherwise in oil and gas sector risk assessment will have no meaning. But please do not ask me a question later, when we do a qualitative risk assessment, why there is no economic perspective? There are qualitative risk assessments as well, okay? We have to do that. But if the risk assessment converges to economic perspective, it is easily understood by the investor, insurance agencies, etc., stakeholders, because it is convenience of understanding, okay? Therefore, it is very popular. So, step number 4, I would like to convert this in terms of composite risk. That is what I am going to do here. So, step number 4, let us say composite risk. I want to complete this. How do I do it? It is very easy. I have the percentage risk, multiply this with the composite exposure value of each department and get the composite risk. Okay? So, forget about the negative figure indicates it is risky, it is at risk compared to the base department, okay? All are negative, you can see here except this, right. So, this figure is now going to be 19.31 by 100, because that is a percentage, multiplied by 5200, is that right? So, if you work out, I will get 1005, I mean rounded off to the nearest possible number. Why? Because I am talking about money. Now, I will multiply this with 10 power 3 and say this in US dollars, because I am now converting risk in terms of financed statements. So, if I do that for remaining departments, I will get this as 166, this as 991, this as 325, this as 487, and of course, this will be 0. Now, I have a question here to the viewers. The question is very easy here, but you have to think it over. Department F is the best department. The composite exposure value is the highest of this department. Because the department has no risk as the base department, the composite risk has become 0, is it not? But please understand, the question is, why the composite risk has become 0 even though the department had a very high composite exposure value? So, that is the question. Even though the department had a very high, a decently high composite exposure value in US dollars, multiply by 10 power 3, why the composite risk has become 0? Okay. Think it over, it is very easy from the inference, you can easily find out that. Okay. I compute this in step number 4, I can do this. Okay. I have to do the ranking now, okay. Risk ranking, I should call risk ranking. Let me do the risk ranking, maybe I will rub this because already I have used this value here somewhere, I will calculate it. I will rub this because for a paucity of space, so I will rub this particular column and replace this column with the risk ranking. Okay. Excuse me for that, but I think in your sheet please do not do that, this has to follow on the other side, but I am rubbing this for my convenience in the blackboard. So, please allow me to do this. So, this is going to be the step number 5/6, whatever you say. I am going to do risk ranking here. Obviously, the department which is having the base reference, the best, should rank the least. It is the best in terms of protection and control. It is the least in terms of indicating, intuiting, influencing risk for the whole plant. So, it is the lowest rank. Why 6? There are only 6 departments. Okay. When you now look at the number 1005 etc., compare them, this is the highest. So, I get this as my rank number 1, rank number 2 will be 991, rank number 3 will be 487, rank number 4 is going to be 325, and obviously this is going to be rank number 5. Okay, these are all ranking. I will repeat again very quickly. Rank number 1 is obtained comparing this figure with that of the remaining. We do not compare anything else. I have a second question to the viewer here. To really get the risk ranking, why we need to go to step number 4? Why can't we get the risk ranking directly from the percentage risk index itself? Why you have to go to the step number 5 or step number 4 to really get the risk ranking? Oh, that is a very interesting question. I can even get the risk ranking just looking at the control and hazard score itself, I can get a ranking. Okay. That is the first level risk assessment what we did. Okay. We said we have to pay attention to these departments. Okay. Interestingly, that is the second question I have for you. First question I already said why this 0. The second question I have is why step number 4 to be looked to find risk ranking. It can be obtained from previous steps also. What difference this would make? Okay. I will tell you the difference here, but you have to answer me. Please listen to this statement very carefully. In step number 1, 2, 3 and 4, you will see that the department A is nowhere commented, is it? We are saying that E and C should be paid attention, F and B can be considered for rewards, F is the best department, and so on. B contributes to the least. We said all arguments about all departments. Department A is nowhere in the dialogue here, but unfortunately department A is ranking top in the risk. See, this is very interesting example. It is a very interesting example. So, this is a hidden contributor. Okay. Please understand why I am saying hidden contributor. Compared to these departments, A was contributing less to the risk, percentage risk in the flow line of the production. But in the overall risk ranking relatively, it took the first rank. So, there are silent contributors who also cause risk to the whole plant. So, our job is to also debug that and find out. This example, and hats off to Frank and Morgan's method, is able to diagnose this kind of issues very deliberately, very clean, very simple and explicit. So, I should appreciate, in fact, I love that this method is able to give me very interestingly a risk analysis in various stages in economic perspective, very interesting model. So, department A is nowhere in the argument here, but it picked up the first rank in risk, relative risk. Please understand, you have to really find out why. Okay. So, the example has been chosen in such a nice manner. I mean, it was formulated automatically. This is a real life example. I mean, it has been done in a specific site. I will not be able to disclose the source of the information because of the strategic issues, but this is a real case study done in one plant of a processing plant of crude oil. So, the department A, B, C cannot be named for vested reasons of the client. This has been done a very interesting example. So, this result was amazing even for the executive authority of the company to really know. So far he was batting and saying that A is the best department because it is not contributing much, okay, compared to these three, but when he saw this result, it was amazing. Okay. This is very interesting. Okay. That is a question asked for you. So, the answer is anyway hidden. Now you will be able to make out the answer. Had you done the risk ranking in the earlier steps, the hidden agenda which was contributed by department A would have not been explicitly brought out. So, you must do the relative risk ranking only after associating the commercial value of this. So, that is a very important task which is emphasized by Frank and Morgan in this method. Do not do risk assessment without associating economic perspective to this. It has no meaning. So, economic perspective is to be associated to risk assessment to really know amongst the players who is most vulnerable. So, that is what I was insisting in the previous lectures. Economic perspective gives actually a sensual meaning. Okay. It makes more sense about the risk ranking or risk assessment or risk mitigation, etc. So, it is very interesting. Now, let us compare quickly departments C, D and E. You will obviously see C, D and E follows ranking next to next, which was expected in the previous steps also. Okay. Now, very interesting question number 3 in this problem. C, D and E do not have the same composite exposure values, though I have rubbed it off, they do not have the same composite exposure values, and the percentage risk index is almost equal. But amongst this, if you notice, the one which is having the positive index got a lower rank compared to these two, but very interestingly department E had more negative score compared to B. It means the control is worse in comparison to B, but if you look at the ranking, B became the second rank and this became the third rank. This is very interesting. It is puzzling, no, because it is very difficult to really know how this is happening. It is expected that okay, you are happy that it is on 4 compared to 2, 3, it is on 4 because it has a positive score. Good, good observation, agreed. But on the same line, if I see this as 2 and this as 3, I would be happy, but that is not happening. This is 2 and this is 3, if my calculations are right. So, again that is the question asked, how this is happening? This will happen only, friends, when you attach economic perspective to risk assessment, otherwise it will not, you will not be able to get this at all. Okay. Now, let us come to the decision. Let us say decisive outcome. One, just because F is the best, can we stop funding towards safety practices in department F? The answer is big no. If you do that, in the next assessment after 6 months, F will become A and A will become F. So, you should not stop the basic funding, should not be stopped, that should be given. Okay. In addition to that, you have to reward the department F, that is the first observation we have. The second observation, even though department A had a positive score which indicates the control measures are better, how come department A is ranking 1? So, it is very important. So, you have to diagnose the problems and fund for risk mitigation to department A. That is the second decision we can make. Okay. More experienced people watching this classroom can derive more information from this, and you would like to share them in the NPTEL website for the business for the viewers benefit in the discussion forum. I will be rather happy, and try to answer those questions which I asked in the class, so that you can share your experience in terms of understanding. That is a very interesting model what we had, which I think you can now immediately apply this in a department and see, or in a plant and see where do you stand. It is very interesting. As a manager, as a participant, etc., you can see this. It is very interesting model, very interesting example which we saw. So, I close the class with this, and we will talk about the accident modeling in the continuous lecture, in the next lecture. So, I believe that you have understood how the economic perspective in risk assessment becomes very interesting and important, so that the hidden contributors, okay, can be brought to limelight in terms of risk contribution to the whole plant on the production. Please understand, this is applicable only to process industry. Why? Because I am talking about exposure values. Exposure is a term related to process and production, of course, not related to any HR or any management systems where there is no exposure to risk. Okay. And here the whole exercise leaves a very interesting homework for all of you, how to prepare the checklist to estimate the hazard and control scores for different groups in a given plant. That is first homework you have. The second homework is how to align the data you have related to the composite exposure value of your department in terms of these 3 segments, and keep it ready. That is important. Okay? That will help you to really do a risk assessment in more interesting manner in the near future. Thank you very much.